like plenty of options there. So thanks. So a year ago, I moved to New York City. I got admitted into CUNY, which is college of University of New York. I used to live in Staten Island. So this program offers me like a 2-year experience there, and it was one of the only like college that got this type of masters, which is a neurodevelopmental disorder type of masters. So I really encourage you guys to actually like just apply as many universities as possible. I'm gonna tell you why, because I applied to Italy, I applied to London, I applied to other states in New York, sorry, in the US, and they were telling me, no, no, no. I've never heard like that many no's in my life. And I swear I was like thinking back and I said like, why do I have to choose biology, right? I'm like, why not marketing? Why not being a doctor or something like that, right? So when I was like admitted, I was like, oh, you know, like I got this, like this is my opportunity, right? So
Yeah, I'll just do it.
okay.
Oh,
So that's the university I'm studying at. Unfortunately, because of visa topics and that stuff, I wasn't able to go back. But I'm doing here theoretical thesis, which basically just means that I'm just gonna read some papers and try to do my thesis based on that. But before I arrived here again into Mexico, I used to work with 2 greatest professors. One of them is actually considered one of the most cited neuroscientists in that field. And I'm gonna tell you a little bit about them and the things that I work in the masters. So I'm gonna present Harry's Dr. Alonso and Dr. Eligrisi. She's from Argentina and he's from Morocco. So both of them were working like in a dual type of system. They were, Dr. Eligrisi was working with autism and Dr. Alonso was working with Alzheimer's. So basically, they were trying to understand the brain, right? They were trying to understand why Alzheimer's, like what is like a biomarker, that stuff, and it's pretty challenging. It was like my pleasure working with them. With Dr. Alonso, I learned that, for example, like if you get like, I don't know, like if you play soccer and you like hit the ball like multiple times with your head, you're probably gonna get Alzheimer's. If you get like yeah, you don't do that. Even also, for example, if you were a kid and you fell down, probably you can get Alzheimer's. I'm not trying to scare you, but that's true. That's something that's true. Yeah, when I was like, you know, like having my class, I was like, I think I'm gonna get Alzheimer's and Parkinson and all the diseases that they were mentioned to me. But it was really interesting because people nowadays like it's for old people. You know, like I'm gonna be like 24, I'm not gonna get Alzheimer's. But that's not true. The scientific community has been proved like Alzheimer's can be developed really, really like in young ages. And I'm not telling you like 30, probably 40. And that's why we were working with that because people forget like, oh, it's not important as COVID, or it's not important as, I don't know, like, what else? Can you give me an example? I mean, cancer. Cancer, that's correct. So we didn't get that enough amount of money, you know, they were like, Alzheimer's, it's not important, right? But they were trying to work together to find something great, right? So Dr. Eligrisi was working with autism. He's my mentor, actually. With him, I discovered that mice can have autism. It's pretty weird, right? Like, how can a mouse be autistic, right? But there is like a genetic modification that they do like to all the mice, the strand they were like working with. And it's pretty awesome because even if you don't believe me, we all are autistic. All of you have autistic traits, and it's pretty normal. Some of us are gonna have like, I don't know, like repetitive behaviors, repetitive routines. Some of us are gonna be like less sociable and that stuff, but all of us, we have autism certain. So it's pretty common. So we both of them, we work in what it's called is thymus extract. We were working with the mice, we were preparing the mice. Thymus extract, the thymus is a structure that is located here when you are like a little kid. That structure is going to help you to develop your antibodies. So when you're a little kid, you have like a little like big type of set of the thymus. When you grow older, the thymus becomes smaller. So with that, we were like trying to understand, like, for example, if I give stimulus to the mice that have like autism, is it going to increase the autistic behavior? They are going to become less sociable. And we discovered that yes. So there is some also, what is it called? Like energy drinks. We were also working with taurine, and yes, you like this guy is addicted to energy drinks. So yeah, even if it's not gonna develop you like autism, probably you are manipulating your genes, and probably your kids are gonna have autism, like are more propense to have it. So thanks to I cannot say like if it was luck, it was my effort. I'm not pretty sure what happened there, but I was like, I was being part of both of the labs for them. So I was able to get co-authority in one of the papers that is going to be published on the symposium of Alzheimer that is going to be in Washington. So for me, it was a really like huge impact, right? Because I didn't believe like someone like 24-year-old guy, like, you know, like I'm just as you know, like I was like, wow, like I co-author. So then I realized that everything is possible, you know, like, and I'm gonna say this, and probably you can take it a little bit wrong, but I can say like science is not for everybody. Like I can definitely like tell you like if you love science, like go for it. Like yeah, it will be a lot of notes that I like I said before, but it's worth it. Like I spent like Monday through Sunday like working like from 7 in the morning to 10 in the night. So it was really, really hard work. And this guy, Dr. Electricity, actually, he developed a device that is called Blink. It's, I'm not sure if it's available here in Mexico, but in the US it's available, and it's an app that can detect autism like in small kids. I'm going to talk a little bit about like what's behind this. I wasn't probably part of the process with this, but he was like continuous, like mentioning me, like they were, he was like trying to explain me what happened here, and I think this is pretty interesting for you. So basically, Blink, autism cannot be detected before the age of 4, and that's pretty bad because they cannot give like cognitive therapy, they cannot give like a proper, I cannot say medication, but the proper like therapy in general for them. So he decided to like understand more about the kids, right? He has a hospital back in Morocco. He's a really, really well-positioned doctor there. So basically what Blink does is, for example, you open the app and it's going to put a cartoon, right, for the kids. So for example, if I just like make like a huge like a clap here, you're gonna blink, right? If I do it again, then you are not gonna blink because you are already used to that. But what do you think happens with the kids?
They're gonna blink.
Blink twice. That's correct. So when they put that kind of cartoon and the same sound like came back, they are going to blink. And it's because they do not get the startle reflex that is called like that. I'm going to explain a little bit about that like after this. So he decided like to just throw that into the public. Why? Because parents are really, really like, they are worried about this, right? If you have a kid, it was like, you know, like why he's having this or he's not properly communicating, this is happening, that, well. So with this, it's a huge impact in the neuroscience community. It's not only studying the brain, right? Yeah, we can open the brain and yeah, like a little mice, we can work with any animal that you want. But in this case, we're having like a great impact in humanity because right now, we're not doing like any like, how can I say, like we're not having like invasive technique, which is pretty good because imagine trying to open like the skull of the brain of a kid, right? So with this, most of like a lot of kids back in Morocco have been diagnosed. After this, obviously you have to go to the psychologist, they have to understand that, but this is like a huge impact. So I was talking about the startle reflex. So basically the startle reflex, this mice presented autism. So in this case, they are, we just put it like in a cage, they just make a sound, and they are going to like just jump, right? In the case of this mice that were created, genetically modified, they were like jumping, right? So with this, we also mentioned the thymus and Sorry. So we are working with animals. Unfortunately, we cannot jump like into humans, right? We're gonna let's say like, oh, I'm gonna use you and open your skull. I'm gonna just like put some electrodes in your brain. You're gonna react this, react. So this was part of the thesis I'm working at. Right now I'm working my thesis is just basically like autism and Turing effects. So basically what I did back in the lab is electrophysiology. Have you ever heard about electrophysiology? Any guesses? Electroshock.
The physics professor.
Why are you like that? Any other guess? No one?
Less violent.
Less violent? No. Not quite. So basically, well, I'm not proud to say this, because they are small animals, they are not making any harm or anything like that. But it's part of being a neuroscientist, like we have to understand the brain of a small species to jump into humans. So in this case, we open the skull and we place electrodes. With those electrodes, we were measuring the beta and gamma waves, and we were like just putting like some shocks like into the animal. So they were like just like measuring how the anxiety levels were. So basically, this tool that you see here and the other one were like well, not this one. The other one was a type of conductual experiment along with novel object recognition. We actually, it's really interesting this because autistic mice, I'm not pretty sure about humans. I know kids have like problems with memory, but in the case of mice, they forgot about stuff. So basically the novel object recognition, you're gonna put the mice like in a small cage, you're gonna put for objects, right? The mice will take like 15 minutes there. They are going to habituate to the cage. And after those 15 minutes, we take it back home and we change one object. So normally we expect like it's a match, right? Like they already know the odor, they know the place, right? So we were expecting, okay, like I changed this object. The match will go to the new object, it's gonna smell it. But in the case of autistic mice, it didn't happen like that. He was like, I was never here. Like he was like, oh, cool, like, it's a new play. But he was like 15 minutes ago there. So with this, we are understanding that also autism can affect memory. This specifically is to measure the anxiety levels. Also, there is a conductual type of experiment in which we just placed like the mice, right? We're just like in a small cage without anything. He was just gonna move around, but anxiety. I'm gonna talk a little bit about that. So what do you think? Like, I'm an anxious person, right? So, and I'm at the party. What would you think would be like? Chatting with people, sitting, drinking. What do you think I will be like doing?
Fidget.
Anyone?
The cell phone?
Cell phone, okay. Other guess?
Fidgeting something, probably.
Yes, trying to distract my mind, but something else. What happened with like the people that suffer with like social skills? What do you
Try to
think?
get out of the situation. Try to like get out of the situation.
That's great. And how do you think I will get? Like,
Like either you go to the extreme and get out of the house, or you find an empty room that you can calm down.
that's correct. An empty room. So in this case, well, the mice cannot jump around. So like, I'm gonna move from here, right? But in this case, like, well, they were like moving all around the cage, just in the corners, and the amount they spend there is the amount of anxiety that they are going to present. They were pretty anxious. A normal mice will just be like there, they will bite you, like they don't care about you. But the anxious mice, they were like pretty scared. Like they were just like, let me get out of here. And that is also another trait of autism. Autism is characterized, now that I mentioned, with social anxiety, with memory loss. And in this case, if you see a kid with autism, is not heterogeneous, you can say. That's also one of the most challenging things that I face here, because Alzheimer, Parkinson's disease, autism is not the same for everyone. That's the main part and the most challenging part of us, the neuroscientists. we have to understand that you have a brain different from him. You have a different brain. Every brain is shaped different. Yeah, we have frontal lobe, occipital lobe, blah, blah, blah. We have all the same structure, but we are built up different. Based on what? Based on experience, academic stuff. Also, if you don't believe it, there has been like a lot of studies that they performed that the most academic things that you can do in your life is going to prevent you from Alzheimer's. They don't know why. Probably it's because of the neurological connection that happened there, like you are like using your brain a lot. But it has been proved that people that have like poor academic levels, they are more propensed to develop Alzheimer's. So that's why you should continue studying. Okay. You don't get that something. That's it. Okay. So with these guys, I'm not just gonna talk about like my life, right? It's pretty boring, I guess. Like like.
No.
It's not.
It is.
Well.
Please say more.
So with these guys, I want you to encourage you like to honestly want to do like something greater. You know, like when I came to New York and I was there, it was like those guys like I are way much smarter than me, right? But that's not true. They are not that smart. Actually, you have really, really good academic skills here. Like I'm living proof of it. Like actually, I can compete against the people that were there. I didn't learn that much about like, the lab, but I learned it in UNAM. So if you have the opportunity to do the internship there, I truly recommend you to be there. And it's gonna be pretty tiring. It's gonna be sad sometimes. You're gonna cry. You're also not gonna eat. Like I'm not gonna say like everything is pink. I'm not. No, I used to like have only one meal per day. Why? Because I have to take care of the lunch, right? They were having the food, but I couldn't be able to do that. So science is something wonderful. Like I cannot describe it. For example, when I see a kid, I can say like he's presenting something, and you're trying to be like, I'm not gonna tell the parents obviously, your kid is acting weird. I'm not gonna say, obviously I'm not gonna scare the parents. Like probably he's presenting out traits, or probably they're gonna have Alzheimer's, But there are like other diseases that are like less common. For example, I learned about Alice in Wonderland type of syndrome, which is pretty awesome. Have you ever heard about it?
No.
Actually, it's really, really like almost none of the population had that. Basically, have you ever watched Alice in Wonderland movie?
Mhm.
She was like big and small, like all the characters were like changing like the size and stuff. So people can actually present that type of symptoms. Actually, your brain, it's presented when you have migraine. So your brain is going to be like, this is not my hand. It's going to look bigger, it's going to look smaller. So it's like, what's happening, what's going on in your brain. But I cannot open the brain, right? So we just speculate like, oh, probably you're like, I don't know, you're ingesting something, like toxic type of thing, and you don't tell the doctor, like, that's a pretty common like thing you will think about, right? But in this case, it's just like they do not say like, for example, it's because of the migraine or the Alice in Wonderland syndrome is like making this person suffer out syndrome. So in this case, we don't know what is related with that, right? We don't know if, for example, the taurine is giving the autism or the autism is being increased by something. For example, glucose is also one of the naughty candies, right? Because they are like gonna be interactive. So in the kid autism, it can work both ways. You can just like chill down the kid, or it's just gonna be like screaming, or I don't know what he wants to do, right? So we don't know why it's causing. That's one of the main challenges about neuroscience. And if you are really willing to offer and sacrifice your life, because at the end it's a sacrifice, right? I used to, live in New York, like, yeah, Times Square, a lot of bars and parties, and, that's so true. Because I spend most of the time in the lab, and it's because I wanted to, not because I feel like I have to go to the lab again. Probably, yeah, sometime, people get tired. But in this case, imagine like in 15 years, my thesis like build up something great. We don't know that, right? Also, interesting fact, I'm not encouraging you to do this at all. So please don't take this sometimes like that personal. But I think it's really good. because there are some harmful substances that, in this case, no, I'm not gonna talk about it. What are you thinking? So, we have been also working, some labs with Parkinson, and actually, would you believe me if I told you that if you smoke, the risk of Parkinson decrease?
Yes.
Yeah, it decreased. But what do you think is going to increase?
Lung cancer.
Lung cancer, yes, and that's not my specialty, so when will I get into that? So what do you think? I talk about it. So, okay, you smoke, you're gonna get Parkinson, but you're gonna get Alzheimer. It's like a duality, right? So the brain is fantastic. Like, like I can tell you millions and a lot about the brain. I can tell you like, oh, this brain, because of that, you can lose your personality, your brain can get damaged, and you're probably gonna die because of a stroke or what. I can give you a lot of details, right? I don't think you're gonna want to hear them, right? But these type of things are like encouraging me, and I think it will encourage people to understand more about it. Like, because I mean, like, smoking, like, seriously, like, what I see like in the news, it's gonna give me lung cancer, throat cancer, and it's going to, I smell bad, I don't know. But no, the substances behind the nicotine, all of that has like a purpose, okay? Even the caffeine that you drink every day, you drink coffee, it's going to help you. It's going to move some neurotransmitter here, it's going to reduce anxiety, it's going to make you more anxious, but it's just based on your own brain. Okay, so with this, it's science. Basically, science says you never know what you're gonna get. You're probably gonna get Alzheimer's, like I told you, or Parkinson's, or maybe, I don't know. No, but I'm not saying this just for you, but there is a lot of research here, and I'm here standing to make you part of this, right? I think you're more biologist, I think, so. Okay, so what do you want to do after you graduate?
That's a good question.
Sorry?
Physics.
Physics? Oh, bio. Doesn't work.
But what about you, Anne?
Medicine.
Medicine. Like neuroscientists and doctors, we're fine there, but it's a good career. Actually, I'm going to tell you something about it. If you study, for example, a master's in New York and whatever state you want to, you're gonna be more able to be accepted into med school. All my classmates were trying to go to med school, but maybe because I don't like that. But they were like, I'm gonna go and do all the experiments, but I didn't see the passion in them. They were like, it's a math. Cool, I'm gonna open it. Yeah, but cool. Yeah, I opened a math. So that's it, right? So we are lacking passion. We're lacking motivation. And I'm gonna share this personal experience with you guys. When I just recently came out of the college, I was like, I'm gonna be the greatest biologist, neuroscientist, yeah, I'm gonna apply to LinkedIn. That was just my CV, a good picture of me, like the biggest, image, like successful person in the world, right? Guess what? I ended up working at call center. Yes, I just worked like a week. Or no, that's not for me. I decided to try another call center. Wow, my English is good. And tell me, oh, probably yes, a little bit there. But after that, I found an opportunity as a science professor. Unfortunately, I'm no longer working there, but I learned something valuable for my students. I was elementary, middle school professor, and you know what my kids told me? I want to become like a scientist like you. And I'm like, are you sure? Well, just stop there, and they repeat me that, right? Why? Why like science? Like I was teaching them astrology, right? Like the sound, and they were like, I want to do that, professor. Thank you, I love your class. And I was like, what happened with my passion? Where I left it was because I studied here and I hate math. With due respect. It's going to help you at some point. I'll be like,
By now, thank you.
you know, it'd be like, no, but, you know, math. Man. Physics, right? I was like, statistics. Oh my God. Terrible class, good professor. I'm gonna tell you who was my professor. But I was like, you know, like I lost my passion. I lost my passion while I was here. And not because of faculty, not because of any other one else. It was because myself. It was because I didn't believe I can do something great. I was like, just like, okay, biology, yeah. I wanted to actually go to med school. So like, biology is going to open me that field, you know, the door there. But I was like, you know, like tired. But when I got this opportunity as a science professor, I saw that the kids need to be encouraged. You're not kids, obviously. No. I don't need to tell you, yes, you're good. No, you don't have to tell them like, oh, I love your talk. Wanna be like, you know. So with this, it's pretty common, guys, here in Mexico also that we do not encourage the scientific community. And I've seen a lot, you know, like when I moved here back, I was trying to find another job, and they were like, "You have a lot of experience." Cool, right? We cannot pay you what you want. Like, I didn't send any like amount, right? Like, no. Oh, you have like 15 years of experience. How am I gonna get 15 years experience, right? Crazy. But with this, I want to tell you like great things are gonna happen. Like even if you don't believe it, like for example, I wouldn't believe like I'm a 24-year-old guy, like having a like being a co-author at symposium that is one of the biggest in the country. It's like wow, you know, your effort paid. So do not lose like your dreams. Like it's kind of like scary outside, and you're gonna quit probably. And like I'm gonna change my name. It's gonna be business. I'm gonna go marketing. Obviously, I think about that too. But it's more like that. I told you guys, if you wanna really spend your life in science, be passionate about it. Because we're lacking that part of the community. We're people too. We are starting autism because we want to understand what is happening. We want to help people. So if you don't think like you are gonna be passionate, find something that you are really passionate about. Because what's the point? Yeah, I can be opening minds. I can be like, yeah, I have a master's in this. You know what? I wouldn't be here. Like if I didn't believe like I feel passionate about what I do. So do not lose hope, guys. Like honestly, it's pretty awful outside. When you're finished, you're gonna remember this time. Like I told you, I'm warning you. It's gonna be awful here, but you're gonna make the difference. And I truly believe you have really good professors. Make really good connections with them. Honestly, in the future are gonna help you. She's not here right now with me, but I don't know if you know Professor Acosta.
Well, let me record that for her.
She will love that. Okay. She can be really strict. Really strict, but that's not bad. I'm gonna tell you what. Don't get me wrong. Because of her, I was able to enter the lab. Because of her, I learned to go on time to my class. She left me once outside the lab because I didn't put my alarm. I was just taking a nap. It was only 5 minutes. She was like, no, you cannot enter. After that, guys, I swear, I have never been late to any lab. I've never been late to any scientific type of job. And it's going to like form you. She's not like the strict type of person is like, no. Take advantage of that, even if you don't believe me. Right now, you're not gonna see that, but trust me, guys, you're gonna be thankful for each one of your professors. Dr. Dolman too. He's pretty smart guy. When I came here, he was like, oh, what do you have been working at? He was so like amazed of what I did, and he was like, oh, we should like work together. I was like, Dr. Dolman, are you like, I'm like, are you talking to me? You're also like, okay. I didn't believe that, but they believed in me. And if they didn't believe in me, probably I wouldn't believe in myself. So yes, be on time, Dr. Acosta, please.
Yep.
And please take also like all the like the things that, bad things and the good things of each one of your professors. Trust me, because you're gonna have, recommendation letters. You're gonna have like some opportunities to open. You never know, guys, trust me, you never know when are you gonna like request for help. Because if it wasn't for Dr. Elsa, I wouldn't be here. She's like my mentor. From here, I learned a lot from her. Basically, I was accepted because of her recommendation letter, because of the dynamic experience that I got. So trust me, guys, it can be really difficult. It can be overwhelming. You will drink a lot of monsters. I did that. Even if you don't do that, please. We're gonna mutate your genes and you're gonna have a lot of problems. Probably not you, but your kids. So we don't want that. We have lung cancer and autism, so please don't do that, okay? So.
That's it? So we can open it up for questions from the audience. Guys?
If the difference between the way the mice act with autism, like it's that different, how efficient is it for us to study them in order to gain
The way,
like, yeah, like the way they like react, you mentioned that they like react different with autism.
yes,
So how efficient is it for us to study them to understand human autism?
that's a pretty good question. So basically, in neuroscience, we start with small models, right? We have to do that. So basically, in autism, there is something called fragile X. Okay. I'm gonna make it as simple as possible. So, you know, like may have X and Y, we have XX, right? So if you see the, like the statistics, most of the guys or boys are autistic because of this fragile X. Fragile X means that the X is kind of broken. It's fragile, as the name implies. So with this, the mice is going to be modified. They modify the fragile X. So the X is going to be like presenting the same abnormality that in a human. So with that, you can just like represent it.
Oh.
So because no, it's okay. My pleasure. So going back to your question, so basically it resembles the genetic structure. So basically we cannot say like, okay, the humans are gonna interact the same, because as I mentioned, autism are varying in different levels. You can present a lot of the DSM-5, which is just like, okay, so challenge side, blah, blah, blah. But in the case of mice, we just modify them genetically. So we can see resemble like in the way they act, in the way that like I was explaining you the startle reflex. So as you see, for example, the startle reflex in mice is exactly the same as the blink eye. It's just like how you can match, but actually we have a lot of challenges there. We cannot, as you say, like we cannot compare them. Like I cannot say like, oh, yeah, I know this trait in the mice, and then I look at a kid, I know it. Yeah, they match, right? We cannot do that. Like, you have another question, right? Oh, this is mental health week. Doesn't remember that. It's still with me. To be honest, is every day a challenge for me. You know, like I was telling my girlfriend that she's here with me. I told her like every day, like, you know, like I don't know if I'm gonna do that. I'm gonna quit neuroscience. You know, I'm not like them. I'm not like a doctor. What I found, nothing. You know, like, and I never repeat that to myself pretty much often. But when I see like the results, it's what motivates me. You know, it's like, I can do this. Probably even if it's just opening the skull of a mice, for me, that's really important because they trusted me. They trust me, their project, they trust me. And they were like, just go to the microscope and do this. And I was like, why? Like, okay, I can do it. But it's just something I'm gonna tell you is just fake it till you make it. That's the phrase that resembles in my head, like yeah, I'm gonna be the best, you know? But it's just a matter of time. you have to prove yourself. You have to throw you to the lions, basically. Just go ahead. And if you think like you're not achieving something, look back. Like I was just sitting right there. I've never thought myself I was giving a talk with you. So it's just pretty small things are going to build up like the empire you're looking for. And do not settle down. Like honestly, if you don't think this have an exit, go all the way. You have multiple paths. You know, for example, if I don't like neuroscience, neuropsychologist, I can change to another type of like, biology. You have plenty of options. Do not believe like, because you choose biology, you're gonna just like be a marine biology. Or like insect pesticide type of organ. It's indeed like pretty much something there. Do not think that. You have to look for what your goals. So that's how I face.
Well, I would just like to back Santi up because fake it till you make it is absolutely right. Because
I'm not joking.
I studied marketing here, I graduated like 2 years ago, but now I work for a law firm out in New York and I do like marketing, video editing. And I remember get hired, he told me like, oh, do you know how to do Photoshop? And I was like, absolutely. And I remember, no, I did not at all. But sometimes you fake it till you make it. So every night I stayed up watching YouTube videos. I would, I don't know, read articles, and I faked it and I made it. So.
Thank you.
We talked about the Alice in Wonderland
Yes.
syndrome. So how does that differ from like other hallucination syndromes, like the Charles Bonnet syndrome?
That's a really interesting question. Because hallucination, they are not real. They are not there. What you see in Alice in Wonderland, you see, for example, the room is gonna get smaller, but it's a room, it exists. You're gonna have your hand, and it's part of your body. So basically, you're seeing real stuff, and like a hallucination, that stuff, there is nothing real there. So there is some misconception there, actually, that's a really good question, because when I was doing the research, I was like, this like type of resemble. But what I read about it is just that it exists. For example, you have your hand here, you're gonna become like bigger and smaller, but it's here. And hallucination is not there. It's like something that is happening here.
But like, is there like a certain change in the brain in regards to that? Cause like.
Yes, actually what happened there, it's not that common, as I told you before, so we have just like a really, really like narrow type of research in it. Basically what happened there is the beta, like we have like waves in the brain, the beta waves are higher in comparison with a normal person, and it's not being proved or discovered because of the migraine. So they do not know if the migraine is actually moving that beta waves that is causing that type of syndrome, or if the syndrome are actually causing the migraine. So that's the only thing that they have been like proved, like up to today. They haven't seen like any neurological changes. They have like the functionality. It's just they are normal people. Just when the migraine is there is when the hallucination, well, the thing happens. I don't know what it's.
I mean, go ahead, I don't know.
So in humans, Fragile X and autism they're like two separate things, right? But my main concern about this is, like for Fragile X, humans tend to have certain physical features and also low IQ. But in the case of autism, they don't have these specific physical features. And also, autistic people can have a low or normal or above the average IQ. So how does that affect using these mice with Fragile X in the way that you study to this later apply to humans?
They're not different. The main challenge of autism, as I mentioned before, is that they do not have like a biomarker, like a specific biomarker. So when they run the DNA, they run the DNA and they found out that there was this part in the X chromosome that is kind of like damaged. It's like not processing properly. So in this case, they took this and put it in the mice, but it's not like all autistic people are going to have like a Fragile X. It's just like a genetic marker that they have found so far. And just like a physical aspect, yes. Remember the DNA of the mice is completely different for humans, but in this case, they were able to match this one. But in this case, the mice is going to grow up normal, 70% we cannot measure the IQ. I don't know if the mice has like a lower IQ or that, but we can measure something else with the conductal part. That's why it's challenging. And it's not like, oh, because Fragile X is going to be autism. No, it's just a biomarker. A biomarker means it's being presented there. Like there are like, for example, in Alzheimer, there is a protein that is called beta amyloid, and it's a phosphorylated type of beta amyloid, and it's going to be present in the brain of people that has Alzheimer, but not all the people has that beta amyloid being phosphorylated. So they found out recently a tau protein, which is another type. So either you have beta amyloid phosphorylated and you have tau. They are both developing Alzheimer, but in different ways. In this case, probably just the Fragile X for him or whatever, and it's different. So that's, you cannot say like it's going to 100% that. It's just guessing at some point, if you want to say like that. So, I don't know.
So if I might add something, it's just, we have models, but it's as you're saying, the models are never going to be exactly the human diseases. It's just the best thing we can do, basically, right? To try to replicate that. And how much does it actually apply to the human disease? It's something that can be debated and is debated in the literature up and down. And what we're hoping is that the model is useful in some way to give us insight, not that it's going to match exactly the human disease. Hopefully we can get,
Because for example, for mood disorders, it's impossible. How can you measure mood in an animal? It's impossible, and that's why we have a delay in all the mood disorders that we study. And actually the paradigms about regions of the brain activated in a particular way, they are changing nowadays. Like the last 15 days, these theories are changing because now we are looking for like a digital like print or like tracking circuits, but not regions. So that's something that is changing in neuroscience. So it's difficult to study more.
I'm going to add something to that. The environment. The environment plays a really important role there. Like where you grow up, your family, your personal experience are going to shape also that. So that's like it's genetics, it's just biomarkers, and it's environment. It's like a triangle. So that's why autistic people are different in every culture also. So that's challenging.
So for us, not here, I'm gonna ask you what your dream university to go to study your master's that you might have not gotten into?
I was trying to become a janitor, so I was applying to Johns Hopkins.
Whoa.
That was
I'm shooting high.
yes. I was like, come down, Santiago.
But that's not a bad thing.
No, but I decided to go to the bar school, uni, like community college, then I set a rate and 9% if you want to apply. It's good. You can check also they're opening this I think it's February. I think in May they opened the applications to it, and they have like a really good neuroscience department there. It's really good. Probably it's not that like NYU. You know? We have no kind of comparison, but this school is pretty good, pretty good for this type of disorder. So if you want to apply to it, it's really good. Really good.
Can we consider those devices organ on a chip to probe the models? Because you were mentioning that what you are looking for are the physiological responses of the mice, for example. And also with this organ on a chip, you can also have physiological responses according to the organ you want to prove. Can we consider that like an accurate model?
Like the organ itself?
Yeah, the organ on a chip, like an alternative.
No, I would say no. And because there is no also like biomarkers, like yeah, we run like the proteins through the gel electrophoresis, like I'm pretty sure you know what is that. So in this case, we also measure the conductal part because we also need to understand how that notification, what are we putting like into the mice, this treatment, how it is affecting. Because if we just focus on the physiological part of it, yeah, we can get the hint of it, but we do not know how it's like expressed, like the symptoms are there, but how they are gonna be like pulled in as a response like in the whole body. So you can do that, but mainly if you work with tau protein, that's pretty much like why they run that. They just look at the brain and that stuff, and they do that because you know Alzheimer's is not like like it's just memory loss. So in the case of autism and any other disease, so like it's ADHD also, like you cannot like just based on the brain, you have to look at it.
Okay, so you're doing the testing with mice. Is there any chance that you're gonna move to like a larger organism before going to study the humans or something?
No.
It just stays at mice.
Yes, and this is because, as I mentioned before, every brain is different. So, for example, ADHD, I'm pretty sure you don't know, but there are 3 types of ADHD. So there is not only one ADHD because I heard people like, I have ADHD. Oh, cool. What is it with hyperactivity or it's just like the deficit of attention? So we cannot like just narrow into one type of ADHD. Autism, it's pretty broad. Like as I mentioned before, the DSM-5, you have to qualify with certain type of like skill, blah, blah. So no, because they were like, okay, the pig, because after mice, usually they use pigs or even monkeys. But we do not know like specifically what happened there. So these mice, it has 3 legs, but it's not behaving the same as this one. And it's not the same as this one. So if we do that, we're gonna waste a lot of animals. It will be pretty expensive. The university are not gonna pay for that. Trust me, they are gonna be like have $5,000 for this. And that's why we need more consciousness about neuroscience, because it's been forgotten. Like it's like it's not affecting like cancer. Like I don't have Alzheimer. I don't care. I don't have Parkinson later. I don't have ADHD. I don't have autism. So people think like that. So no. Right now, I don't think it's probably in 30 years. I assume. Yes, it will take a long time.
Anyone else? I do have a question. Just so we can get an idea, of course, it's going to be different for every person, but how long does it take from start looking for universities to go do a master's or graduate school in any case in the US? How long does it take from just the point you start looking to actual admission?
You want to know the truth? Honestly, I was just bored of my life. Like, let's go to another country, like probably New York. I was like, Times Square. A lot of models and local artists. So I was like, yeah, I'm gonna play there. So basically, I just looked for the program that I was interested in, and it was like I applied on May, and they accepted me like December, but they were like passing like to the second step and the interviews and that. So it was pretty fast because this program we were only like 10. So they were looking for more students, but I will think and I'll figure out like almost like a year, like for you to look for a proper university because you need recommendation letters. You need to look for the acceptance rate because if I apply to John Hopkins, right? Yeah, I'm not the 1% of Santiago, right? Probably yes. I don't know. I didn't apply, to be honest. But you should look for pretty good acceptance rate. You have to look for the program and see the subjects. It's pretty important because, for example, I cannot change from one school to another because this type of classes and course that I just take, it's just being offered. If I look for another university, for example, Las Vegas or Miami, like I want to look there, I can't. And that was because I didn't check probably the program. But if I apply to another neuroscience school, they will match some of the courses and you can definitely move around it. So it's a matter of like a year.
Yeah. So I just wanted to hear you say it so that all of you. Plan ahead.
Other questions? So please, let's give him a big applause.
I'm nice.
With the logo.
But I'll open it, right?
Just so everyone knows, Santiago was one of the students that actually opened the doors for the internships in Curitiba and the Neuroscience Institute. So all of you who have gone there or who will eventually go there should know that it was because of the excellent work that Santiago did. And of course, the appropriate recommendation from Professor Acosta. So I think that deserves another round of applause for the service. Yes.
Well, yeah, you can ask me, but I'm not going to say what I'm going to say.
Congratulations.